welcome back to my channel. I apologize because I was quite busy last month, so I couldn't make any videos about the integration. So without any further ado, let's start with the chapter integrations. So in STPM syllabus, there are two types of integrals. One is definite integrals and second type is indefinite integrals. So for definite integrals, they have certain limits for the integrations. Let's say I integrate the fx from a to b. That means I set boundary limit for my integration, so I can get the full answers without any variables. I will get variables, but I will get a complete answers. So in STPM, if they come out with definite integrals, that is a bonus mark for you, because you can check with calculator. You can press in the calculator by enter the certain limit from a to b. Let's say I have 3x squared dx and I integrate from 3 to 5. You can check your calculator and you will get the answer is a value and without any variables. So for indefinite integrals, you will get an answer with variables x, y, anything, and you must add a constant at the end of the answers, because you don't know you integrate from where to where. Let's say you possibly to be 2 to 5, 3 to 6, anything. So you must add a constant at the end of your answer, so you will get the correct answer. Right. Alright. So integration is basically the reverse of differentiations. So let's say you have a and you differentiate a, you get b. So if you want to get back the a, you just integrate it. So that means they are completely reverse. So if you don't know how to integrate some things, try to think about the differentiation and reverse about it. That's the answer. So from differentiations, we learned already when we have y is equivalent to a x to the power of n. When we differentiate the whole terms, we will put down the power of the x and we get na and x will copy back. However, the power reduced by 1, right? And here is how this is the normal differentiations formula that you need to understand and you need to memorize. For integration is actually the reverse of differentiation, right? So when we have y equals to n a x n to the power of minus 1, that means I have here, if I integrate it, I integrate the whole terms, that means I integrate with respect to x, and I will get back the answer is actually a x n. I will get back the same answer. So for the first part, we already derived the first formula for the integration. It's actually the reverse of differentiation from the ax n. So when we integrate ax to the power of n, in integrations with the power, we are increased by 1. As you can see, from differentiation, the power is reduced by 1. So for integration, its power increased by 1. However, you can see we are actually multiple with the n. That means we multiple with the original power. Right, so in integration, we are divided with the new power. That means we are divided by n plus 1. That means we are divided by the new power. For differentiation, multiple. For the integration, we are dividing. Alright, so and we add a plus c here since it's indefinite integrals. So let's solve for this example. Let's say I have 4 plus x, 4 minus x, and over cube with x. So if I want to solve these questions, I will say you must expand it for your easiest. So if you expand it, you will see that I will separate part by part. So you can see if I expand it, I will get, actually here is 4 plus x, 4 minus x. It's actually equivalent to a plus b, a minus b. So you will get a squared minus b squared, right? So we get 4 squared minus x squared. It's actually 16 minus x squared. And here is, I change it to x to the power of 1 over 3, so I can separate it very nice. So let's say here is 16. Here is actually 16. I can change it to 16, right? Alright. So if I want to separate out term by term, so it's actually 16 over x to the power of 1 over 3 minus x squared. X squared over x 1 over 3 is actually x to the power of 2 minus 1 over 3, and it's equivalent to x 5 over 3, right? So minus x to the power of 5 over 3, and here is the x, and it's equivalent to the 16 x to the power of negative 1 over 3. I bring out here, and minus x to the power of 5 over 3. So with respect to the x, and now you can see how we integrate it term by term. So we do it term by term. We start with the 16. So 16 is a constant, we put it back, and x we copy back, and here the power increased by 1, and we divide by the new power. It's like that. So power increased by 1, divide by the new power. So when power increased by 1, negative 1 over 3 plus 1, you will get 2 over 3, right? And we divide by the new power is actually 2 over 3. And minus x, 5 over 3, the power increased by 1, so we get 8 over 3, right? And divide by the new power is 8 over 3, and add a plus c at the end, since it's indefinite integral, the limit is not stated. So you simplify it, you will get the answer is 24x to the power of 2 over 3 minus 3 over 8x to the power of 8 over 3 plus c. So here is how we solve the indefinite integration fractions. So if I add a certain limit, let's say I add 6 to 10, you just substitute inside the calculator, and you will get the answer, right? It's actually 10. You substitute it, here is 10, and here is 10, and substitute one more time, it is 6, and 6, and you minus it, you will get the answer. So let's see for the second example. So for this example, they basically want to test you, you understand that root x is x to the power of half, right? So, and I can expand it. Expand it, do it term by term is the most easiest way. So let's do it. So x to the power of half times x, you will get x to the power of 3 over 2, right? And minus, here is 2 root x, 2x to the power of half, plus here is x, and here is minus 2. So with respect to x, so now it's term by term already. I can integrate it term by term. So as I said, all the integration, the power increases by 1. Here is plus 1, here is actually 1 and plus 1, here is actually 0 and plus 1. The x is actually 0. Since x to the power of 0 is equivalent to 1, anything to the power of 0 is actually equals to 1. Let's say I put 10 to the power of 0 is actually equals to 1. You can press by your calculator. So now, when we increase power by 1, we need to divide by the new power, right? So it's actually x to 3 over 2 plus 1 is actually 5 over 2. And divide by the new power is 5 over 2 minus 2x half plus 2x half plus 1 is actually 3 over 2, and divide by the new power. And here is x squared, and divided by the new power is 2. And here is minus 2x divided by 1, right? The power is 1, okay? So it's nothing, okay? And we add a plus c, since it's an indefinite integral, we don't know the limit. So we simplify it, we get 2 over 5, x to the 5 over 2, minus 4 over 3, x to the power of 3 over 2, plus x squared over 2, minus 2x plus c. So here is how we get the answer for these questions. So it's very, very easy. So as I said, this formula you need to memorize. I will highlight with pink color for you to memorize it, that you need to know how many formula you need to memorize, because in STPM they don't require you to derive it very hard. So you just memorize all the formula, you can just substitute inside, and it will be very fast for you to solve the questions in STPM. Alright. So let's see. The second, I will tell you how to derive it. From differentiation, we already learned the chain rule, right? So recall back the formula, the chain rule. If you forget, you can recall back my videos and revise back. So we have y equals to a fx to the power of n. Fx is a function, functions in terms of variable x, right? Let's say I have 5x squared minus 3x plus 5. Here is the functions, right? So we have a constant outside, right? So now if I want to differentiate it, I definitely put down the power here, right? So it's actually n a same like just now, and fx, the power reduced by 1, right? We copy back the fx, and n, the power reduced by 1. And what we do is we multiply with the f prime x, where f prime x is the differential of fx. So this one is we already learned from the differentiation chapters. So for the reverse of it, we will get integration. Means that if we integrate the whole terms, we will get back the same things. So now we create the formula to that is when we integrate k is a constant, and we ax plus b is a linear function. Note that that is a linear function to the power of n, and we integrate with respect to x. The power is actually increased by 1. This is the same thing we already learned from the first formula, right? So now we increase by power of 1, we still divide by the new power, and now we are divide with the a. What is a? A is actually f prime x. If here is the fx, here is actually the f prime x, right? Since we have ax plus b, let's say y equals to ax plus b. If you differentiate it with terms of x, you get a, right? This constant, and x and b, you differentiate constant, we get 0, right? So you get a. So here is how the formula used, but with certain condition that n not equals to -1. If n equals to -1, your denominator will equivalent to 0, and you get invalid answer, and it's only applied for the linear functions ax plus b. So in order to do that, it's actually the same things for the chain rule, but now we reverse in. So you need to memorize this formula also, because it's quite easy to solve the questions. Look, let's say I have these questions. So it's integrate 8 over cube root 1 minus x to the with respect to x. So how we integrate it is actually we need to put everything on top to the numerator. So it's 1 minus x to the power of 1 over 3 negative, because we change from the denominator to the numerator. And now if you want to integrate this whole thing with respect to x, so now 8 is a constant, we just copy back the 8, and here is actually the fx. I don't care what is the power. As you can see, 1 minus x is actually 8x plus b. As long as it's a linear function, we can apply this formula. So I don't care the power. The power is just like tricky. As long as see what inside the bracket is a linear function, then you can apply this formula, right? And you just copy back the function, and the power now is increased by 1. So increase by 1. So when you power increase by 1 is equivalent balance to 2 over 3, right? Negative 1 over 3 plus 1, yes, 2 over 3, and you divide by the new power. And what you need to multiple is actually the differential of these terms. So how we differentiate? So let's say you have y equals to 1 minus x. That means what inside the bracket we differentiate it, divide the x, we get negative 1, right? Here is 0 and here is negative 1. So you multiply with negative 1. And here, many students that forget how to divide the term is f prime x. Here is your fx and divide by the f prime x. You don't forget the f prime x here. So you will get the answer is, and you do it, you will get negative 12. You put outward and you simplify it, negative 12, 1 minus x to the power of 2 over 3 plus c. Since it's an indefinite integral, so plus c. Okay. So it's how you get the answer. So for second example, you can try it and you can pause the video to try it, alright? So I will show you how to do it. So it's basically I will just take out the constants to 5 and I put this to the numerator part. So it's 1 minus 3x to the power of negative 5 dx. So I don't care what is the power. It's just like tricky part. So as I see what inside the bracket is a linear function. It's in terms of 8x plus b is negative 3x plus 1. So now as I say, when I copy back the function, I copy back the constant, and here as I see these terms, I know that okay, this one is a linear function, so I can use this formula. I use this formula, that means I copy back the constant, and now I copy back what inside the bracket, 1 minus 3x to the power. Now the power I increase by 1. Negative 5 plus 1 is equal to negative 4. And negative 4. And now I need to multiply with what is the differential of this inside the brackets. So we have y equals to 1 minus 3x. If I differentiate it, I will get negative 3. Negative 3, right? So I multiply with negative 3. And we add a plus here since it's indefinite integral, and we will get the answer is actually 1 over 30, 1 minus 3x to the power of negative 4 plus c, and here is the answer. So as I say, everything is the same. We just need to see that as it is linear function, we can apply the formula. So let's see some summary for this. So what we learning today. So in first, if we have y equals to n ax to the power of n, if we integrate it, when we integrate it, we get the answer is reverse of integration. So if we ax to the power of n dx, when we integrate the whole terms, we will actually get the a, we copy back since it's a constant, and x, we copy back, and the power is actually increased by 1. In differentiation, the power reduced by 1. In integration, the power increased by 1. In differentiation, we are multiple with the old power, and integration, we are divide by the new power. Here is the things, and we add the constant here since it's indefinite integrals. And second, if we have to integrate the k, where k is a constant, 8x plus b and dx, and you can copy back the constant and 8x plus b. What inside the bracket you copy back, and the power increased by 1. Okay, increased by 1. And we will divide by the new power, is the same thing. But only thing is, since it is linear function, as I said, that means it's something linear function, that means it's 5x plus 3, 3x plus 2, anything. Now, we just need to differentiate the whole term and divide it. So, in this case, we will divide by a. Because if y equals to ax plus b, where a and b are constants, and we will get a, right? A plus 0 is actually a. So, here is how we do the integration. It's very, very easy. So, in next video, I will I will teach about the integration by substitution, which is the method and to deduce the new formula that is f prime x and fx, and next video will be the logarithms and exponentials. Alright, thank you for watching.